Solving complex equations. So here we divide mainly the complex equation into two kinds. With the very first one, quadratic, and the second one is higher order complex equations. And when we think about a quadratic, here we need to recall the concepts of b squared minus 4ac, which is also named as discriminant of the quadratic equation. And we have already learned that if b square minus 4ac greater than 0, the roots are real and distinct. Like if alpha and beta are the roots, then this alpha and beta will be real and also distinct. And if b square minus 4ac equal to 0, there we get roots are real and equal. And if alpha and beta are the two real roots, then as per this condition we get alpha is equal to beta. And if b square minus 4ac less than 0, we get roots are complex. So if b square minus 4ac greater than 0, then the roots are real and distinct. B square minus 4ac equal to 0, roots are real and equal. And if b square minus 4ac less than 0, then the roots are complex. And when it comes the higher order roots, higher order complex equations, there we have to remember a few concepts. Like when we think about a quadratic equation, we know that there are two roots. Every quadratic equation has two roots. Yes. Those two roots can be either real. Both the roots can be either real or both the roots can be complex. And when we think about a third degree equation, which is named as a cubic equation, you know that it consists of three roots, and how these three roots can be formed. Yes, here we get one chance, which is all the three roots are real. We can have all the three roots real, and one root can be real and the other two roots can be complex. So here we get a question: can two roots be real and one be complex? Can two roots be real and one be complex? Is it possible? Here the answer is a big no. Because in case of complex equations, if a complex number is a root, then the other root will be compulsory the conjugate of the first complex root. So it says that if a root is a complex number, then there will be a second root which is also be a complex number, and that will be the conjugate of the first root. That means a complex root cannot be alone. So every complex root will be having a pair which will be the conjugate of the other root. So two real and one complex won't be existing, and also three complex never exist. And when it comes a fourth degree equation is also named as quadratic equation. You know that there will be four roots, and here what is the combination of roots? Yeah, all the four roots can be real, all the four roots can be else complex, and two roots can be real and two roots can be complex. So these are the possibilities you could find while doing fourth degree equation. Okay. So here let's consider a question. It is given that z minus 2i is a factor of z raised to 4 plus 13 z square plus 36 is equal to 0. Solve this equation. So here when we consider this question, given that z minus 2i is a factor of z raised to 4 plus 13 z square plus 36 is equal to 0. So here z raised to 4 plus 13 z square plus 36 is equal to 0 can be considered as the dividend, and z minus 2i is a factor. So we have learned already these type of questions from the topic algebra, and we know that there are two methods to solve this question. The method one is using long division. Long division is also known as synthetic division. And the second method is using division algorithm. So let's consider long division method. When you take long division method, you know there should be a dividend and a divisor, and the dividend is already provided here as z raised to 4 plus 13 z square plus 36 is equal to 0. And to make the divisor, let's consider the first factor. The first factor is given as z minus 2i. And we know that if one root is complex, then the other root also will be a complex, which is the conjugate. So we can say the second factor as z plus 2i. So there are two roots now, z minus 2i and z plus 2i. So to find the divisor, let's multiply these two factors. When you multiply two factors, we get z square plus 2iz minus 2iz minus 4i squared. So we get the resultant one as z square minus 4i squared, which is z square minus 4i squared is equivalent to plus 4, as we know that I squared is minus 1. So here we get the divisor as z squared plus 4. So now let's go for the division. Our dividend is z squared plus 13 z squared plus 36, which is divided by z squared plus 4. Sorry, this is z raised to 4. And when we make the division, the first term is z square, z raised to 4 plus, so when you multiply z square into z square, z raised to 4. Now z square multiplied by plus 4 is 4z squared, and when we subtract we get 9z squared plus 36. Now add 9, so that we get 9 into z square is 9z squared plus 9 multiplied by 4 is 36, so that we get the remainder 0, and the quotient is z squared plus 9. So now we got three factors. The very first factor is z minus 2I, and the second factor is the conjugate of first one, which is z plus 2I, and the third factor we got now as z squared plus 9. And from the first factor we can say z is equal to 2I will be the root, and from the second factor we get z is equal to minus 2I, and from the third factor we get z square is equal to negative 9, or z is equal to square root of negative 9, which is square root of negative 1 multiplied by 9. We get it as plus or minus 3 into root of minus 1 is I. So here we get all the roots, which are z is 2I, z is minus 2I, z is plus 3I, and minus 3I as the solutions. Now let's see how to do this question using division algorithm. So let's recall division algorithm, which is nothing but dividend is equal to divisor multiplied by quotient plus remainder. Dividend is equal to divisor multiplied by quotient plus remainder. In this question, dividend is given as z raised to 4 plus 13 z square plus 36, and a factor is provided as z minus 2I, so that with the help of this factor and its conjugate we'll be able to find the divisor, like as a factor is z minus 2I, the next factor will be z plus 2I. So if you take the product of this one, we get the divisor, and already we found this product in the previous question itself, and we got it as z square plus 4, and as it is provided in the question that it is a factor, as it is a factor the remainder becomes 0. So here the unknown term is q of x. So let's write the given division algorithm as dividend. Our dividend is z raised to 4 plus 13x squared plus 36 is equal to divisor. The divisor is already we found here z square plus 4 multiplied by the quotient plus the remainder 0. Okay, so dividend is equal to, that is z raised to 4 plus 13 z square plus 36 is equal to divisor. We already found divisor as z square plus 4 multiplied by quotient plus remainder 0. Now here, as we do not know the quotient, we have to make an assumption for quotient. We can assume this quotient as a quadratic equation, because your dividend is a fourth degree and divisor is second degree, so quotient also will be second degree. So let's assume the quotient as something x square plus ax plus b. So in this question we can assume it as z square plus az plus b as q of z. Forgot, it should be q of z. So we get this expansion as z raised to 2 plus 4 multiplied by z square plus az plus b. Now take the product of the right hand side. We get z raised to 4 plus a z cubed. When you are multiplying z square into z square multiplied by az and z square multiplied by b, we get it as b z square. Now when we multiply 4 plus 4 with z square, we get plus 4z square. So plus 4z square, and 4 multiplied with az, we get plus 4az plus 4 multiplied with b, we get plus 4b. So when you do the addition here, it's z raised to 4 plus a z cubed plus b z square plus 4z square is b plus 4z square plus 4az plus 4b. Okay, now let us make a comparison of both the sides. So here left hand side we have z raised to 4 plus 13 z square 13 z square plus 36 is equal to z raised to 4 plus az cube plus b plus 4 z square b plus 4 z square plus 4az plus 4b. So when you make a comparison on both sides, let's make a comparison. When you make a comparison on both sides, let me change the color of the pen. Okay, see, z raised to 4 is equal to z raised to 4. Now when you compare the term of z cube, so here left hand side we have a z cube, but in right side we have 0 z cube. So when you compare z cube, we get a equal to 0. Now even the same thing can be done for z square. Now compare z square terms. Here we have 13 z square and here we have b plus 4 z square. So when you compare z square, we get b plus 4 is equal to 13. b plus 4 is equal to 13, or it gives you an answer b is equal to 13 minus 4, which is 9. So we are getting a is 0 and b is 9. Now we can take our quotient. We assumed our quotient as z square plus az plus b. It can be written as z square plus 0z plus 9, or can be written as z square plus 9. So here we get the quotient as z square plus 9. Hence we got all the required items to find the solutions. So now let's write all the three factors. The first factor is z minus 2i, second factor is z plus 2i, and third factor is z square plus 9. Gives you z is 2i, it gives you z is minus 2i, and it gives you z square is minus 9. It implies z is square root of minus 9. Square root of minus 9 already we have done as plus or minus 3i. So we get the solutions 2i minus 2i and plus or minus 3i. Okay, thank you very much.